Here's something that will blow your mind. You and a common house mouse share a surprisingly intimate evolutionary trait that most people never even notice. While you're probably aware that humans and other primates have fingernails instead of claws, what might shock you is that nearly every rodent scurrying around your neighborhood has developed the exact same feature. Yes, rats, mice, squirrels, and hundreds of other rodent species sport thumbnail-like nails that are remarkably similar to our own. But here's where it gets controversial. This tiny anatomical detail might actually explain why rodents have become one of the most successful animal groups on Earth, colonizing every continent except Antarctica. A groundbreaking study led by researchers at the University of São Paulo and the Field Museum of Natural History has uncovered this hidden world of rodent thumbs, and the implications are far more significant than you might expect. The research team, including study co-author Rafaela Misagia, admits that even she was completely unaware of this phenomenon, despite years of studying these creatures. When I engage people in conversations about our findings, I always begin with a simple question. Were you aware that rodents possess thumbnails? The response is almost universally negative. I myself was completely ignorant of this fact, explains Misagia, who serves as an assistant professor at the University of São Paulo in Brazil. Despite dedicating years to rodent research, I remained completely oblivious to the intricacies of their nail structures until this project at the Field Museum opened my eyes. To understand why this discovery matters, let's first clarify what we mean by rodents. These mammals belong to a specific order characterized by their signature feature, a pair of continuously growing front teeth that they use for gnawing through their food. This diverse group encompasses familiar animals like rats and mice, as well as guinea pigs, hamsters, beavers, and countless other species. The scope of this research is truly staggering. Our planet hosts more than 530 different genera of rodents, encompassing over 2,500 distinct species. Our investigation covered 433 of those genus groups, representing specimens from across the entire rodent family tree, reveals co-author Anderson Feijoa, who curates the mammal collection at the Field Museum of Natural History in the United States. The research methodology involved painstakingly examining preserved rodent specimens housed in the museum's extensive collections. This approach allowed the scientists to study hundreds of different species in detail, something that would be impossible with living animals alone. Prior to conducting this comprehensive study, our understanding was fragmented. We knew that some species possessed nails, others had claws, and some lacked thumbs entirely. There were tantalizing hints suggesting that rodents equipped with thumbnails also employed these appendages for food handling, notes co-author Gordon Shepard, a neuroscience professor at Northwestern University. And this is the part most people miss. The results were absolutely stunning. The team discovered that a whopping 86% of rodent genera possess thumbnails, with claw-bearing thumbs appearing independently multiple times throughout evolutionary history. This overwhelming prevalence suggests something remarkable. All modern rodents likely descended from a common ancestor that already had thumbnail-like nails. But wait, there's more to this story. The researchers didn't stop at just cataloging nail types. They took their investigation a step further by analyzing how different rodent species actually use their hands during feeding and foraging behaviors. We leveraged the power of modern technology, using the iNaturalist app to examine thousands of photographs showing various rodent species in their natural eating behaviors. We supplemented this digital approach with traditional research methods, diving deep into textbooks and scientific journal articles, Shepard explains. Armed with this comprehensive behavioral data, we reconstructed the entire rodent family tree, categorizing species based on whether they manipulate food with their hands versus those that rely solely on their mouths for feeding. The patterns that emerged were fascinating and crystal clear. Take guinea pigs, for example. These thumbnail-less rodents typically don't use their hands to handle food during eating. In stark contrast, thumbnail-equipped species like squirrels demonstrate sophisticated manual dexterity, skillfully manipulating nuts and fruits with their hands while nibbling away. Now here's where the story gets really intriguing and potentially controversial. The researchers propose that these seemingly insignificant thumbnails might actually be the secret weapon that allowed rodents to conquer the globe. Nuts represent an incredibly energy-dense food resource, but successfully opening and consuming them demands exceptional manual dexterity that most other animals simply don't possess, Feijo points out. Perhaps rodents' thumbnails provided them with the evolutionary advantage needed to exploit this unique and valuable food source. This specialization may have then enabled them to diversify extensively across different environments, since they weren't competing directly with other animals for the same nutritional resources. But here's what makes this discovery even more remarkable, and this might challenge everything you thought you knew about evolution. Primates, including humans, represent the only other mammalian group to have independently evolved nails instead of claws on their thumbs. This means that rodents and primates developed this trait separately through a fascinating process called convergent evolution. The moment I became involved in this project, examining rodents' nail versus claw structures, my mind immediately gravitated toward understanding their lifestyle patterns, their habitat preferences, the diverse ways they utilize their hands beyond simple feeding behaviors, Masagia reveals. I was already aware that primates, who predominantly possess nails rather than claws, typically lead arboreal lifestyles in tree environments. We decided to test whether this same correlation existed in rodents, and our findings were remarkable. Rodents equipped with nails showed a significantly higher likelihood of living above ground or in tree habitats, while fossorial species, those adapted for digging underground, were much more likely to possess claws rather than nails on their thumbs. This connection between nail structure and lifestyle adds another layer of complexity to the story, suggesting that thumbnails aren't just useful for food handling. They're also perfectly adapted for life in the trees. The study emphasizes how even the most seemingly insignificant anatomical features could serve as powerful windows into understanding evolutionary history and success strategies. It's a reminder that nature's solutions often hide in plain sight, waiting for curious researchers to uncover their secrets. For every single rodent specimen that contributed to this study, I'm confident that none of the original collectors could have imagined that someday someone would dedicate serious scientific inquiry to examining those tiny thumbnails. Feijo reflects with obvious appreciation. Museum collections continue to serve as inexhaustible sources of new discoveries, constantly surprising us with unexpected insights. The complete findings from this groundbreaking research have been published in the prestigious journal Science, adding this thumbnail revelation to our growing understanding of mammalian evolution. But here's what I find most thought-provoking about this discovery. It challenges our assumptions about what makes certain animal groups so successful. We often focus on obvious traits, like intelligence, size, or speed. But what if the secret to evolutionary success sometimes lies in the smallest, most overlooked details? So here's my question for you. Does this research change how you think about the relationship between humans and other animals? Are we more connected to the rodent world than we ever imagined? And what does that say about the paths evolution takes? I'd love to hear your thoughts. Do you think this thumbnail connection is just a fascinating coincidence? Or does it reveal something deeper about how similar environmental pressures shape entirely different animal groups in surprisingly parallel ways?